All right, everybody, I'm hoping to be back soon, but today's not that day. So I wanted to make one video going over how to answer all these questions in your homework. So this homework was mostly about different types of lines, whether they're parallel or perpendicular or skew, and then the different types of angles that come about when you have lines and a thing called a transversal. So on problem number one, it's talking about parallel versus skew. So parallel, when we're looking at a plane that is parallel to GFE. If you look at GF and E, that's on the left-hand side. So the plane that's going to be parallel to it is going to be the right-hand side. Just pick any 3 points, D, C, B, or H in any order and write the word plane in front of it. Those are going to be parallel because they never intersect. And when you get into lines, though, it's a little bit trickier because you can't just say parallel lines or any lines that don't intersect, because then we also have this thing called skew lines. So the definition of parallel lines are going to be two lines that are coplanar and don't intersect. So you have to imagine two lines that a flat surface could contain both of them, and they don't intersect. So it says, what are the lines that are parallel to AB? When you look at AB, GH or HG, ED or DE, and FC or CF. Those are going to be the lines that are parallel to it. Okay. Now skew, on the other hand, the way you can think of skew is kind of like if you have the highway and then an over ramp or an under ramp. So those things are not going to actually intersect, but they're not going to be parallel either. So that's called skew. So it says, what are going to be the lines that are skewed to AB through D, AB through D? I was just running with the lines that you can actually see. I wasn't looking at like DF or something like that, but you can see that DC and DH are both going to be lines that don't intersect AB, but are not parallel to them. Okay, non-coplanar lines that don't intersect. As I said, there's many other ones. If you are looking at lines that aren't drawn, for example, DF would be one of them. I think DG would be another one that doesn't, that it would be skew to AB through D, but I was just running with the ones that can be seen, as it says in the instructions. The next one on number two, I was just trying to make sure that you understood notation. So you have AB and you have CD, and they have one arrow and one arrow, meaning that they are parallel. Then if you had two arrows and two arrows, that would be used if you had other parallel lines in the same diagram and you've already used one arrow, one arrow. Now the perpendicular marker, the way you're going to do perpendicular is just that right angle marker. So the little box is going to tell you that they are intersecting at a right angle, which means they are perpendicular. Now this gets a little bit more confusing. You're looking at these two different lines and a line that intersects them. So you have two different lines and you have a line that intersects them called a transversal. If you have your two lines, there's an interior and there's an exterior of those two lines. There's the same side of the transversal and there's opposite or alternating sides. So when they tell you 3 and 7, 3 and 7 are bottom left, and connected by a line, and therefore they would be corresponding because they are both in the corresponding location, the bottom left. Now, when you're looking at 3 and 6, 3 and 6 are on the interior and they're alternating sides, so it's going to be alternate interior angles. 1 and 8, on the other hand, are alternating. They're switching sides of your transversal, but they're on the exterior. So we're not super clever with the name. It is alternate exterior angles. Then when you look at 4 and 6, they're on the same side of the transversal, but they're on the interior, so it'd be same side interior angles. You got to be careful with like 5 and 8. Those are switching sides, but we already have a name for those. Those are called vertical angles. So those are not alternate exterior or alternate interior. Those are just vertical angles. Same thing with like 6 and 8. Those are on the same side, but we already have a name for these. These are called linear pairs. So 6 and 8 would not be same side interior or same side exterior or anything like that. It's just going to be linear pairs. Now this is the part that usually messes the most people up. And the reason being is, let's say we're trying to use 18 as a reference angle. 18, it's possible for it to be interior or exterior. So that messes people up. If you're talking about the horizontal lines, then 18 is between them, so it's on the interior. Now, if you're going over and looking at the two vertical lines on the right, 18 is on the exterior. It's not between my two lines. But to make things even more confusing, if you look at this vertical line and the one in the middle, so the left vertical line and the one in the middle, 18 now becomes interior again. So an angle can be interior or exterior a lot of times, depending on what the two lines are and what the transversal is. So on number 4, it says, all angles that are alternate interior angles with 18. So here's an intersection where the 18 is, and then up here is an intersection where the 5 and 6 are, and they're connected by a transversal. So I can figure out what the alternate interior angle is with 18. That would be 8. Now the other one would be 18 and 16. That's just picking two different lines in a transversal. Okay. Now you're not going to have 18 and any angle with the 21, 22, 23, 24, that intersection. It's not going to have a alternate interior angle because 18 is not even interior between those two lines. Next, all angles that are same side interior angles with angle 8. Angle 8 and angle 11 would be same side interior, and 8 and 19 would be same side interior. The next one, alternate exterior angles with angle 1. Alternate exterior angles with angle 1, that would be 1 and 8, those two lines and a transversal, and then 1 and 12 and 1 and 16. And the last one is corresponding angles. Every angle that's corresponding with 11. Now this is where people mess up. 11 is bottom left, so they assume every single bottom left will be a corresponding angle. And that's true as long as a line connects the two intersections. So 11 and 7 are corresponding angles because there's a line that connects those two intersections. 11 and 3 are also corresponding angles because there's a line that intersects both of those intersections. 11 and 23 would also be corresponding angles. But then you look at 11 and 17. Now, even though they're both bottom left, since there is not a line that connects the two, then they would not be corresponding. 11 and 15 would be other ones where you're like, well, they're both bottom left, but they're not connected by a transversal. So they are not those special angles. Lastly, use the words sometimes, always, never to fill in the blanks. Non-intersecting lines are only sometimes parallel. They can also be skew. So it does not guarantee that they're going to be parallel if they don't intersect. Perpendicular lines, it's impossible for something that intersects at a right angle to never intersect. So that one would be never. And the last one is skew lines are never going to be coplanar. If you have skew lines and you have a flat surface that contains one of them, the other one is going to shoot right through it. All right, hopefully that helped out. Thanks for watching.